l'invitation. This is the extension of my Norwegian. I can do also good Jule, but I don't think it's the moment. So if you don't mind, I will switch into English and I will share with you my slides. Okay. Good morning. Now in English that I feel more confident than in Norwegian. It's a pity because it would be very nice to interact with you in your own language, because the topic that we are going to address today is pretty interesting. At the beginning, we put this title, Organizing Open Science, that I think is a big challenge, and is probably what the librarians, particularly academic librarians and research libraries attached to research processes, will do it the next 15 or 20 years, organizing open science, which is a big deal. But to be a bit more concrete and to make this talk affordable in more or less half an hour, 40 minutes, so we can have a discussion, I will focus on FAIR, metadata, and the new approaches that we have for knowledge organization systems. That it happened to be that we call them now vocabularies and also semantic artifacts, which is something that I don't agree very much, because we don't need more things or more names to call things. We need to pin down concretely the tools that we have in library science to address the new challenges that open science and the new infrastructures have in front of us. So more or less, my talk will focus on the open science as the background, as I told you, where you are going to have your next challenges in your academic career, in the academic libraries, in the research libraries. I'm always referred to open science, not to that umbrella term. I always refer to open science as a mushroom, because I think that we need roots to be in the floor. Actually, it is a biologically incorrect mushroom, because the mushrooms, they don't have roots, but we need to make open science to flourish in a responsible research and innovation soil, and also in a base of a reward system, new infrastructures, and new research integrity. And also we have a big challenge on addressing the intellectual property rights in the new environment, recognizing the right to be open as much as the right to be protected. So this is the whole context that I always try to draw. But today I will just focus on the big infrastructures, and in the in one of the aspects that I think they are crucial to address the open science from the infrastructure perspective, which is the main standards, and also in terms of library science, the standards for knowledge organization, for information organization, and now for data organization. That is a big challenge. But first of all, I will just tell you how I came to open science, because I remember that in the last Digital Libraries conference that I was attending in Portugal a couple of years ago, people asked me, what did you come up to open science? And I say, well, metadata drove me to open science, and now open science drove me back to metadata, because what I'm going to tell you is what I'm working right now in FAIR project, in the context of making data fair and interoperable in an interdisciplinary research environment, which is really challenging for the next years in the shaping up the open science paradigm. And also I would like to show you a bit of the FAIR principles that I always said that this is the magic acronym. Everybody loves saying findable, accessible, interoperable, and reusable. And that's fantastic. It's the best fortunate acronym we have ever. Probably in a few years, it will be like LASER. How many of you remember what LASER stands for? Probably FAIR data will be the same. But the point is that in this very happy acronym, findable, accessible, interoperable, and reusable, that for us librarians is like a dream of every single information system, it gathers a lot of challenges. And all these challenges, they are basically challenges based on metadata. I will just go deeper on this, but I will tell you from the policy to the real practice, and from the real practice to the policy, how it's not a very a back and forth path that is not very easy to walk back and forth in the policy path to the technical path and all the way around. And also how knowledge organization are the core and the FAIR principles, and how we call now, as I told you, semantic artifacts. And also this comes with the context of the EOS, of the European Open Science Cloud, that probably you have heard about that, which is the big infrastructure, is one of the challenges, is one of the big things that the European Commission is putting so much money on, that make it happen. There's a big infrastructure for research data for the whole research environment in Europe. These are the challenges that we have in addressing in the Open Science Policy Platform. Here you have the 8 challenges that we are talking about, where we need to make open science happen in Europe. And also in the transversal way, you have the stakeholders that we are keen to work on this. One of the main stakeholders is the research libraries, of course, and also the research academic institutions, universities, research performing organizations, that we have a real challenge on make this happen from a practical point of view. That's why I put you here, FAIR Data and EOSC, in a light color, because for me, they are the more practical challenges that we can address from a technical point of view with the library and research organization information. And also the big challenge, which is the rewards and incentive system. That is something that is not up to us, but is something that is really the bottleneck of the open science to happen. If we go to the final report of the Open Science Policy Platform, if I was giving you a talk today in a policy level of status, I will talk about you the new attributes that we envision for the new knowledge system in the 2030. The point is that we are just changing the target. Before we thought about 2020 as the horizon for open science and all open access publications to happen. And now, since we didn't reach our objective, we move forward the target date. So that's very easy to have 10 years to make it happen. But in this point, I will not tell you about the attributes of the new knowledge research system. I will tell you about how we also, in this final report of the OSPP, we focus also in the research data management, how we have to manage licensing in terms of reusability, and how we have to manage this dichotomy of fair and open data, because making data open is not the same as making data fair. And making data open is about licensing and intellectual property and privacy in many cases. For example, I'm working also in a project called Fair for Health. We are working with data from clinical research. And when you have clinical data, you have a big layer of GDPR, a big layer of privacy issues that you cannot go through and make the data openly available. But anyhow, you can make the data fair, because the data could be anonymized, could be not openly available, but they have to be at least findable. This is my distinction that I will go probably a bit further in my talk, the distinction about findability and discoverability. When you can't find something, is that you know that it's there. In our library catalog, we find things that we know that they are in our library. But if you go to Google, you discover things, because sometimes you don't know what you are looking for is already there. Okay, so this is one of the big challenges that we have in the FAIR data and in the research data management. And also the FAIR data has been established in the Horizon 2020 program for those that you are more in the front line helping researchers to accomplish the requirements of the research program, Horizon 2020, and now in Horizon Europe. You know about these guidelines, and the guidelines for FAIR data management, they have this particular approach of findable, accessible, interoperable, and reusable data, which is about metadata. And also this kind of tricky answer when you have a problem that is as open as possible, as close as necessary, which is something that makes us happy in a context when sometimes we don't know if we can open the data or not. But this is the mantra of the open research data, of the research data management. And also we would like to have this open by default. But also fair data means not only findable, accessible, interoperable, and reusable. I always say that I need more R's. We need also to make information reliable, and we make information reproducible. There are 2 R's that we cannot miss up when we are dealing with the management of research data. And also to just have the whole picture, we are talking about policies, we are talking about conclusions, we are talking about going from policy to practice, from practice to policy. But then we have also to underline or highlight a bit the legal aspects of all this. In June 2019, it was approved the new directive of open data and PSI, because it's the a review of the reusability of the public sector information, that actually it recognizes the research data as a part of the public sector information. When we are dealing with publicly funded research, we are dealing with public sector information. So all these principles and also the directive explicitly address FAIR principles as the way to go to make them to all the research performing organizations. They have to guarantee that they have open access policies to make the data also available. But when we come up to the magic findable, accessible, interoperable, and reusable, if you look at the principles, all the principles, they have a lot of metadata. For example, to make them findable, you need to have metadata and unique and persistent identifiers. And also to make it reusable, you have to have metadata and also domain relevant community standards. When we go to the interoperable layer is where the vocabularies and the research, research artifacts and the semantic artifacts for research data come along, because the vocabulary is to follow FAIR principles. To make interoperability is one of the big issues that we are dealing with these knowledge organization systems. So I always say that findable, accessible, interoperable, and reusable, that is in a policy level, is 80% of metadata and 20% of PID. Sometimes I say we can negotiate. If I'm talking to Freya project that they are engaged with PIDs, I say, well, probably 40 PIDs and 60 metadata. But it turns out that it's a very technical issue and it's very related with the way we describe information in the domain and also out of the domain with vocabularies and knowledge organization system to share the knowledge in a different layer. This is a more affordable explanation of the FAIR principles that comes from the SOC project, which is the project that is coordinating SESTA, which is the Social Sciences Infrastructure Esprit in Europe. And they just try to explain better, more like not so much on the detail of the principles, that they are very much on metadata. But even if you try to explain in a very basic way without making very much specific terms of technical perspective, you also have metadata and the findability. You also have the possibility to make machine readable, which is also about metadata. In the interoperability, you have metadata and control vocabularies. And of course, in the reusability, you have to deal with the possibility to understand the licensing that you give to the data. So this is what I was telling to you, that metadata are at the core of the FAIR principles. Metadata is the way we can make the data findable. And also when you come to the reusability, we have, if we look at the interoperability framework from the European Open Science Cloud, for example, one of the recommendations is to make your metadata CCO with a Creative Commons license that is publicly available. So you can hide your data, but your metadata should be there, even when the data are hiding for intellectual property reasons, for privacy, or for whichever is the the reason to hide the metadata, the metadata and the vocabularies that they are around them, they have to be publicly available. So this is the real challenge. And also there is a big amount of vocabularies, a big amount of metadata schemas, a big amount of domain-specific metadata. And what we are working now is how to sacrifice, in terms of a specificity of description of the metadata, how to sacrifice the domain-specific metadata to domain-agnostic metadata. It's something that we have been doing in the libraries with the Dublin Code for years. That's what we have done in the repositories. But what happened with the repositories is that it doesn't matter if your publication is from chemist research project or your publication is for social science or humanities. At the end, you have the same metadata. But if it comes to the research data management, the data that they produce in astrophysics, they don't have anything in common with the data that they produce in anthropology. So how can we deal with these different metadata standards for domain-specific descriptions that they really make the data reusable and really interesting for the domain? So it's what I said, using the Tim Berners-Lee, when he was talking about the URLs, he always talked about that the URLs, to be a good at URL, you have to be a cool URL. And a cool URL was that is persistent and you can maintain it over the time. A cool metadata is that those metadata that they are rich, which is another discussion that I have in the domain of data principles, which is rich metadata. Rich for who? For the system, for the machine, for the domain researcher, for the public at large, for the citizen scientist. What is rich metadata? This is one of the questions that we have to balance. And also when we are in these approaches of a technical level, we can define that the cool metadata for open science, this is an acronym that I have invented, cool metadata for open science, are those that you have only a difference between data and metadata is the mode that you use. Because metadata help to be fair, data make the data fair. To make the data fair, you need the metadata fair. Okay, and metadata is not just for publications, it's also for software, for services, for algorithms, for computer code, etc. And also metadata is not only for description and discovery, it's also for contextualization. This is what really makes data useful for the researcher, when they have relevance in the context that they use it. One of my favorite jokes is to put in front of Zenodo collection of data. A person, for example, imagine that I did with one of my colleagues in the university from statistics, and I put him a collection in Zenodo of statistics data, and I say, reuse those data. And he say, I don't understand anything that is here. What is the problem about the policy and the practice? The policy in the Horizon 2020 asks you to put your data available in a repository, trustworthy, blah, blah, blah. So it's a 0-1 hypothesis. You put it or not put it. If you put it, you just click the box and you're done. But what is the difference between doing and do it properly? That you give contextualization and you give richness to those data for the person in the domain to be capable to reuse. Okay, so, and also in this context of making cool metadata, we need to make them machine readable metadata as well as human understandable, because it's the way that we can work together in a very big high performance computer environment. Because if we are thinking about research data for research, it's not that we are talking about 4 Excel spreadsheets. We are talking about giga and gigabytes and petabytes of information that is making data-driven research part of the successful research and innovation system that we are building up. Okay, so if we think about that, we are working with digital objects. So every single data of the data that we are envisioning is digital object. And if we think about these digital objects that they have to have different machine readable format, they need to have a PID, a persistent identifier, and also they need to have metadata, at least at different levels, descriptive, administrative, and structural. This is domain agnostic, because also we can think about descriptive, structural, and administrative at domain-specific level. For example, imagine that you're working with data that they come up from a synchrotron. They have an administrative production, which is absolutely completely different than the administrative description that you can do as a librarian to a collection, okay? So, and these metadata processes, we need to have this digital object fair. And to make this digital object fair, we need mainly two elements, which is the PID and the metadata. And also, this is related with the findability. This is related with the also with interoperability, and the metadata is what I say to you, 80% of metadata and 20% of PIDs, because the metadata are in almost all the features or all the principles of accessibility, interoperability, reusability, and findability. Okay, the PID is crucial for the findability, but the metadata are crucial for all the other features of the FAIR data. So this is my joke. This is a picture that I took in one of the conferences of research data, that I have this discussion with Barry Mons, that is one of the creators of the FAIR principles. And he said that we can discuss this percentage of 80% and 20% always when we think about that we are working with digital objects. And also, if we come up with the repositories, also to keep the digital object fair, because the main condition of the repository at the end is that we want to keep the data, to save the data, to maintain the data, to preserve the data, but to make the data fair goes farther, because we have to make the data findable, and we have to make the data also visible for researchers, and how we can expose this fairness, okay? So this is the researcher that is interacting to the repository with a graphical user interface, and he interacts with the descriptive metadata. Sometimes, if he's an expert in the domain, he will need more metadata. But if he's just a citizen that we expected in the European Open Science Cloud, it could be not such a specific metadata. So there is also a possibility that you have different language for the data, which is something that is interesting, that sometimes the data are in a language that you cannot understand. And also, sometimes you have to integrate all these interoperability issues at multilingual level, not only having a vocabulary of your or a new vocabulary for your domain, but also have it in an interoperability, interlingual interoperability. Okay, so this is what we are trying to work in the DCAT model. DCAT model is the standard of metadata that is used in the European data portal, because we are creating the European Open Science Cloud for research data. But it's already created another infrastructure, which is the European data portal, that works with link open data and with DCAT description, which is a baseline metadata model based on application profiles that can help us to pin down the domain and also the other interoperability level within domains. We are working at the same time as the people work in the DCAT too, in the repository level. We are also trying to work in the infrastructure level with the different domains. For example, imagine that we have cultural heritage data set. We can transform the specific data of the cultural heritage on a domain agnostic information. Same thing if we have a geospatial data set, if we have a geographic data set, an astrophysics data set, and we want to transform it in a catalog from a repository and have a common catalog for all of this. So the first solutions that we came up and we have been working on FAIR is FAIR project are persistent identifiers, metadata and how to align and integrate those metadata between different metadata catalogs within different domains, and also what we call fair semantics and semantic artifacts. Guess what is semantic artifacts? The vocabularies, the thesaurus, the ontologies, the same thing that we have been talking about in knowledge organization always. But now it's more glamorous to have to say that we are dealing with semantic artifacts. Tomorrow we will have a workshop of a working session about how to describe semantic artifacts with metadata that make the semantic artifacts fair. So everything has to be fair, not only the data, but all the surrounding elements that they are coming with the whole infrastructure to make this happen. So we are back to the problem. This is back to the problem on the whole theory of the metadata, and is what I was collaborating in Metadata 2020, and is what I was telling all my life that I have been 20 years on research on metadata. And I always say that metadata are like toothbrushes, because everybody thinks that there is a very good idea, but everybody wants to use their own. It's not a question that you want to share. No, I want to use my metadata standard. And I have heard so many times, you don't know about my field. In my field, we need always the same. But this, I have heard that in the cultural heritage, in Europeana, in these digital libraries infrastructures. But now dealing with data is much more toothbrush, because every domain needs a very, very particular level of description to make those data that they are usable for the community. And then we come up to the EOSC, the European Open Science Cloud, the big infrastructure where all those data should end up at the end. What is the European Open Science Cloud? Of course, there is a fantastic policy definition from the Commission Moedas, when it was launched the idea in 2016. And also we have millions of definitions in the SRIA, which is the strategic planning for the infrastructure of EOSC, that it was published early this year. We have millions of technical definitions as a federated, global, accessible environment for the reuse of research data in the whole Europe, and also to create fair data and fair services and so forth. But for me, the EOSC is what I said, where the wild things are, which is a story, is a tale for kids, where there is a monster that a guy that he thinks that when he goes to the land of the monster, everything is big and dark. And this is what is EOSC for us, big and dark. If I ask you, every single of you listen to this talk, what is EOSC for you? I'm sure that every person will come up with a different opinion, because it's such a big collection of infrastructures, a big collection of domains, a big collection of services, marketplaces, catalogs, domain-specific data, data-driven analytics, artificial intelligence is such a huge thing that it's very difficult from your day-by-day work in your academic library to find out what I have to do for EOSC. That's a real challenge for the librarians. And also another challenge is when I was working in RDA, the Research Data Alliance. As you know, the Research Data Alliance is the organization that is a grassroots organization that we are working on different aspects of research data. And we try to come up with agreements, best practices, policies to make the researchers working with data the life easier. But I was an RDA ambassador for interdisciplinary research. What is my concern? My concern is that we have different working groups with different disciplines addressing different problems within the discipline. Research Data Alliance for Social Science, Research Data Alliance for Life Science. But what happened when it comes to the real findability kingdom, farther than findability kingdom, which is within the domain, the discoverability kingdom, where we want to discover information among different disciplines. So this is where we are working in FAIR, that we are trying to create a metadata layer where we can share different domains, or we can make proposal for metadata catalog integration to support cross-disciplinary FAIR uptake. What does it mean? This means that if we have different domains, for example, here is what I have been working in the design of the pilot, the big infrastructures, those are the 5 clusters that any of these clusters, they aggregate different infrastructures, different S3s, all them together, they aggregate 45 of the S3s in Europe. And they are in the domain of astrophysics, life sciences, environmental science, photon and neutron, and social science and humanities. In every domain, they have their own metadata, they have their own knowledge organization systems, semantic artifacts, or whatever, and they have their own infrastructures, services, and different domain-specific analytics. But what happens if we want to address this from a perspective of a user that goes to a graphical user interface and he wants to have data about COVID-19? And COVID-19, I want probably to discover data from the humanities, the people that they have been analyzing COVID-19 with a perspective of anthropology or something like that, or people that they have been addressing COVID-19 from the, clinical information in the EOSC Life Kingdom in the life sciences, or you have biomedical information from biological experiments, or you can have photon and neutron information from a synchrotron that you can address whatever it is. What happens when I want to find information that I don't know that is already there? I want to discover, because research is based on discovery, not on findability. Libraries are based on finding things, but the research is based on discover things. And the discoverability will reach up when we can describe in a very semantic enough and semantic oriented, in a domain agnostic approach, all these data collections for different domains. So this is where we really want to experiment, if we can integrate different clusters, different domain-specific infrastructures in a common catalog. And for this, I want to just pin down you a bit, because just underline that the libraries, we are here. We are in the long tail of science. We are not dealing with big infrastructures. We are not dealing with big data. We are not dealing with life sciences infrastructures that they are addressing different challenges, blah, blah, blah. We are in the long tail of science, where we have different little repositories, and in our repositories, more or less, we have multidisciplinary content for all these disciplines. And all these repositories, they should aggregate the content independently of the domain that they are addressing on the approach. So this is what is really a challenge for the libraries. But what we are doing in FAIR is trying to use all these big infrastructure, thematic infrastructures, and try to address all these specific metadata catalogs. That also, this was a big discussion that I posed it to you. What is a data catalog, or what is a metadata catalog? In the first workshop that I organized on this task, I got 25 different definitions. And all of them, they are nuances who you understand for a metadata catalog or for a data catalog. For the librarian perspective, it's clear that you have a catalog to reach something. Not necessarily you have the book there. But sometimes the repository has the data and the metadata. But the infrastructures, they don't have the data and the metadata. They have only the metadata catalog, because the infrastructure, they need a lot of storage somewhere else to deposit the data. So this is a different perspective depending on the domain and the things that you are dealing with. But we are trying to address all these big domains, but also the repositories. You can have astrophysics information in your repository, because your university has a department of physics and they are having a project with astrophysics and they create metadata related with that domain. Why we don't need to aggregate that? That would be fantastic. Why not? And also, those are the two domain agnostic metadata that we are addressing. One is the one that I told you before, that is my colleagues of the repositories are dealing with, which is the CAT and the CAT application profile. And the other one is DDI CDI, which is a new approach for the DDI metadata model for data, that specifically there is a group that is sponsored by CoData, another institution dealing with research data, that they are studying specifically how to come up with a DDI profile for every single EOS compliant catalog. So this is what we have to analyze now and try to go through. And also we have a good alliance, which is B2Fine. As you probably know, B2Fine is the research data catalog that EUDAT has provided, and they are experimenting with this mapping between different metadata schemas and metadata standards to make this happen. So we would like to do a testing, a pilot on the metadata catalog integration. But the challenge of the whole thing, and it's just, I think I would just finish with this kind of conclusion, that more than a conclusion is provocative challenges for you guys, is the challenge is the inter or cross-disciplinary research. We have a very interesting discussion about what is multidisciplinarity, cross-disciplinarity, interdisciplinarity, or superdisciplinarity. At the end, the researchers, they say, you know, we work together. That's the point. But how we can come up with these boundaries of discoverability in an inter or cross-disciplinary environment. And also, we have to avoid the toothbrush effect on the metadata standards. We have to come up with these agreements, with these standardization bodies, with these lose the specificity on the benefit of the findability or the discoverability, how you can just use the other metadata standard if it is not exactly created for your domain. This is to try to avoid a toothbrush effect, which is not a technical point of view. Sometimes it's kind of a political thing. And also how we can address the data, the metadata catalog integration. What is the metadata quality? This is the question of $1 million. And it's something that we were discussing for years in Metadata 2020, just thinking about repositories and thinking about Crossref and these kind of infrastructures that they are more devoted to publications and data. But metadata quality, not only at a schema level, is that elements or properties, but also at semantic artifact of vocabularies level, which is also creating ontologies and domain-specific and cross-ontologies to make this happen. And what is good metadata? The good research outcomes, whatever they are, publications, whatever they are, data, whatever we want to have openly available and demonstrate to the world our excellence as researchers, they have to include good metadata. And the difficulty here is to balance, which is good metadata. The rich metadata, millions of properties, the good metadata in terms of very semantic oriented with vocabularies, or the cool metadata, which is the ones that I defined you before, that is kind to find out the ones that they are better for the discoverability instead of the findability. So these are the challenges that you probably will have to address in the next 15 years. Good luck. And thank you very much for your attention. And I'm very happy to take some questions and following this discussion on the social networks and by email or whatever you want. Thank you so much. Tack. Good job.
Thank you, Eva. This was a very interesting talk. So if anybody has any questions or comments in English or Norwegian, we'll try to give them to Eva and see if we get some answers. I haven't heard the example with the toothbrush. I think I might steal that one. That was a very good example about metadata and sharing of standards. Yeah.
I would like to discuss with some of the librarians in attendance, if somebody is dealing with research data management, how they deal with in the reality, in the practice layer, how they deal with the fairness, which is at the end is a big difficulty that we have to find out how to do it in the day by day. So I think this is the point of the discussion.
Yeah. Because we're thinking here, it is not the actual libraries who are creating the metadata here.
Yeah.
It's the researchers themselves who are creating the metadata.
Yeah, the researchers, they create the domain-specific metadata, and sometimes you have to translate them in a more interoperable domain. So, and also the question is which kind of professionals we need to address these new challenges, because the librarian, they cannot know everything about every domain. So sometimes you probably, if you are working with sensors or synchrotrons or these whole automatic data infrastructures, perhaps you need an expert in the domain to deal with this more than a librarian, or perhaps you need this intermediate level of professional skilled person, which is what we call in English data steward. I don't know how do you translate that in Norwegian. In Spanish, it's super difficult to translate, but it's kind of a person that is a curator and a facilitator with the data. It's not necessarily a data scientist, because the data scientist goes further on the analysis. It's not a data librarian, because the data librarian goes in another domain, which is the preservation only of the description. That is that person that is a facilitator of the research through the metadata. So for example, in the Melbourne University in Australia, they have these kind of professionals where they call third spacers, because it's a third level. They are no researchers, they are no librarians. They call them third spacers because they are in the Melbourne data analytics platform, and they are these people that they are facilitators with the researcher. They have a researcher profile, but also they have a lot of knowledge of fairness. So this is a kind of probably for those that you are involved in the academia and library science, thinking about how we can evolve our profession to a more specific domain-oriented approach on this data management thing.
Is one idea the embedded librarian, that the librarian goes into the research community as to spread the gospel of metadata?
Yeah, yeah, yeah. That's a good point too.
But the fair
We have also a very nice question from Niels. Hello, Niels. Nice to see you. Well, no, see you. Say hello to you from here. And he said that the data stewards, who should train them? Are the library information science department the right place? Asking for a friend. Thank you. But the point is that we need to evolve a lot. The traditional library information science, I don't think it's prepared to train these data stewards, but probably with a bit of more computer science, a bit of, you don't need to be a programmer, but probably a bit more skilled on computer science, that would be enough. Data analytics, data visualization, helping and being a good facilitator, a good translator, because these people that they are working as data stewards, they help the the researchers to transform their needs of information in the data that they want to manage, or the tools that they need to process those data too.
So I've got another question here from a colleague who is organizing the conference, who is a student. And as this is saying this is a new area for them, but from hearing you speak, they understand that this is a very exciting and a future area. So they're asking what sort of information sources they can use to try and read up on this and follow this. Do you have any recommendations for new beginners?
Well, for new beginners, I will recommend you to start with very fair project documentation. We have been producing so much information. We have a lot of deliverables, a lot of reports, but I think it's probably a good starting point, because it's the way that it's producing the theory of fairness and how to address the fairness on the practical basis. It's not an academic paper. Well, of course, we write also academic papers, but it's just more about this, what have to be in a trustworthy repository. What is fairness for fair and trustworthy repository? Or what are the repositories that we have to address this? Or what are the best practices for this? Also, we have a work package about, I'm not very much involved from that. I'm very interested and I try to join them as much as I can. But also we have a work package on education for fairness. So who has to educate those people, or where can you make these new unicorns that they are the data stewards, that they are super overall skills, and they have a research profile, but they have also skills of data management from a perspective of information science too.
Got another question here about which relates to COVID-19. So if we think about COVID-19 as a case, how did open science research respond to that?
Well,
any ideas?
That's a very good question, and also is a very good example, because I think every single of us, we are putting the example of the COVID-19, because even if we have been stuck in this bidimensional kingdom that we're in the screen all the time, we are in lockdown, we have been just stuck in different places. But the good thing about the COVID-19 is that really makes putting on the table again the right to science, which is a fundamental right, and really have shake all the academic system of evaluation, all the academic system of knowledge production, of knowledge valorization, even going to the kingdom of the patents of the chemists and the pharmacologist companies. It's having so much pushing the whole research system that I think is something that we will remember in 10 years' time. Do you remember that year that we were all stuck in different places, but it was the year of open science? And I think it's absolutely, and also, a couple of weeks ago was approved the first draft of the UNESCO recommendations on open science. And I'm assuming that at the end of November, 193 member states of UNESCO will approve these recommendations. And I think it will be a before and an after these kind of things that we have to thank, if we can say thank you, COVID-19. So yeah. I think is the real advantage of demonstrating that we need an open science.
Yeah, it's like a sort of stress test of the system.
Exactly.
In some way. And a colleague just said to me that we got a speaker later today from the University of Tromsø, who works with research data there. So if anybody's interested in this subject and wants to hear a Norwegian perspective on this, that will be at 1 o'clock. Philip Consett from Tromsø we'll be
Right.
talking about concrete examples from a local university.
And also, I think in terms of open science, you have moved forward a lot in Norway, because Norwegian universities, you are one of the cases that DORA declaration has underlined and has put in highlight of the research evaluation, because the Norwegians, they have transformed the CAM, which is the career assessment matrix, it's a matrix based on the open science principles. And you have transformed that open science matrix of career assessment in a Norwegian base. And I think it's very interesting how you are adapting to the new research evaluation, because at the end is the bottleneck that really will change the approach of open science.
There's a very long question or comment in the chat. I don't know if you can see it, Eva.
Oh, it's Norwegian?
It's in English. It's about,
okay.
I think it's relating to health information. The health information in Norway.
Mm-hmm. Oh, it's NOMAD. Yeah, I know the vocabulary. Mm-hmm. Yeah, that's a point. Mm-hmm. Well, this is about what I was mentioning about that sometimes you have to translate between domains. And also you are talking about a North European country, which is Norway, with the level of English in general population is very good. And also you're talking about a domain of medical sciences, health services, where they are very good users in English. So if you come up with this problem that you have to translate the metadata into the language and you have to go back and forth, this is your own dictionary translating the searches, but at the end of the day you probably will need to have an ontology underneath the whole system that can translate automatically these things for you, because if not it will be an nightmare in the future. I mean, very interesting question. Yeah,
I've got a question that's maybe a different perspective on this, but we're talking a lot now about university libraries, but I wonder about public libraries, and especially this with citizen science. Mm-hmm. Is there any discussion there about using public libraries as a way to organize citizen science, maybe together with other types of libraries or other types of organizations?
That's a fantastic question, and I love it because I'm super pro citizen science, and I always says that the natural point of connection of the citizen scientist is the public library. But also there is a big question among the citizen science practices that I have been discussing for the last year. Actually, we wanted to create an interest group in the Research Data Alliance about citizen science, or what we call community created data. Because sometimes it happened when we were making the COVID-19 recommendations for research data in the RDA working group that we created. I was working on this community created data, which is all the data that they help the research. For example, the data that you have in your phone, because you just register in a place, or you have these data that they follow you and they contract tracing on these kind of things, that they are super valuable. But how do you deal with those data? That they are not based on a very specific research project. They are not in a publicly funded project. It's not a European Commission or whatever project. What do you do with all these data that they are so significant and so important for the whole research? And that's why the citizen science, it was in my slides of the domain in the long tail of science, because there are millions of data that citizens produce there. probably that would be a good, I don't know if, again, I don't know if the common public library can assume these services. So it's creating a new specific role for the public library. I don't know if the public library is prepared to hold of these data scientist production or community oriented systems on the library, but it would be something that could be experimented. It may be not in every single library, but in a particular library, it could happen.
I thought about as the public library is the interface towards the public, and some libraries are working with maker spaces and coding for kids and this sort of thing, so it could be a part of that sort of initiative.
Yeah. Indeed.
So are there any final questions for Eva?
Very much the chat. I think somebody wrote to me only. Oh, it was I don't know, which is the question. Oh, it was in the Q&A. Somebody's asking me that he sent a question, but it's not seen by the others. Probably is the Q&A? No.
Oh. Okay, the last chance to.
I can be discussing with you for years. It's fantastic discussion.
Yeah, I think that the conclusion from my side is it looks like a very big area with lots of challenges and with challenges it gives us chances to explore new things, and the FAIR principles themselves are created by scientists, aren't they? Not by librarians.
Yeah, so they are created by scientists.
That's quite interesting that they found these things which are very, very central to library science.
Absolutely,
so
it's legitimize us very much. Actually, all these creators, if you look at the list of the creators of the FAIR principles, Mark Wilkinson, Barry Mons, there are many authors of that foundational principles, and they are all researchers, but they are so sensitive with the importance of knowledge organization and how to manage. And also the discussions the problem is that now everybody talks about FAIR and everybody talks about metadata. And sometimes for me, this is a permanent déjà vu situation, because we are having the same discussions that 20 years ago for the digital libraries, but now we are thinking about digital infrastructures. And the only difference is that its specificity is bigger and the need of a storage and the amount of information is huge. So we are thinking about high performance computer. We are thinking about how to deal with cloud systems, services, analytics. That is huge. But the main questions about metadata, interoperability, vocabularies, they call it semantic artifacts, they need a new word to discuss. But at the end of the day, it's things that we have been discussing for the last 20 years in the digital libraries and the digital infrastructures.
Okay.
Eva, now a participant has raised their hand, so I'm just going to give him the floor for a moment.
This will be the last. This will be the last question, because we have to finish at 10:05.
That's very good timing.
So please, Niels.
Yeah. Well, thank you, Eva. It's been great.
Niels.
Hi. Good to see you. It's been a great talk, and I just wanted to, ask simple question based on my experiences when trying to find good research data, is that I often end up having to deal with quite simple Dublin core.
Yeah.
And I wonder, is that the solution based on necessity, or should we could we make it richer? I mean, for making the data, the data are probably made findable from a librarian's perspective, but in order to make it more discoverable, I wonder, do you have a short comment on that? The Dublin core use?
Always when I have this discussion, and you know me very well, and I'm a Dublin core person for years and years, when people come and say to me, do you think you can describe the research data with Dublin core? And I say, at the end of the day, you could, but you shouldn't, because it's not created for that, the metadata model. It's not created to describe this kind of digital object. Of course you can. And at the end of the day, this thing happen when you go to the repositories and the libraries, that they are very much accustomed to deal with the Dublin core. And you know, the Dublin core is the main metadata standard for OAI PMH. That is the standard that works on the whole repositories of publications. And the librarians sometimes, oh, the data come now, we have to deal with the data. Well, what can we do? And they put the data in the same repository, and they end up describing the data with the same metadata that they describe in the repository. I have this discussion with a colleague that she's the responsible of the Center of Research in Spain of the repository of publications and data. And she was leading a working group on the how to make a mapping between the data site schema, which is more or less a simple data descriptive metadata standard for data, specifically for data, to Dublin core. And I say to her, it's absurd and from a technical point of view, but I can understand you that for the practical point of view, since you have your repository, you need it. So at the end, I think the Dublin core came in the whole structure because of the practicalities of the research libraries.
Yeah, I'm sure. It has to do with the tradition and something being as standard as DC. Yeah.
And also there's the people know it. It's something that if I know something, I don't want to learn anything else. Because for the librarians, it's always the same story. When you learn all the answer, they change you the questions. And you say, no, I know the answer, don't change me the question. So the Dublin core is the answer, but it's not the right answer for the question of research data.
Great, thanks.
Thank you, Niels. Take care.
Yeah, you too.
I think you're mute, David. David, you're mute. Sorry.
Thank you, Eva, and thank you, Niels. That was what I was saying, and I kept talking English, but maybe I should talk Norwegian now. Vi tar en 10 minutters pause, og vi begynner igjen 10:15.